Welcome everyone to our POSPac MMS webinar for mobile mapping today. Thank you very much for joining our webinar. Seems like there's a big audience today and we really appreciate that. I'm very happy to host this session today. My name is Nico Jäger and I'm the product manager of POSPac. I'm joined by Christian from our support team who will present together with me today. Plus, he will also assist in the Q&A session. In addition, we have our marketing team here in case there's any technical issues, so hope that's not the case. So this is the third webinar in our mobile mapping webinar series. Should you have missed the previous webinar and you are interested to watching them, you're welcome to go to our webinar center at applanix.com/webinar.htm. Okay, so some words about the logistics today. The presentation will last approximately 40-45 minutes, and then we have a Q&A session. The webinar is going to be recorded and shared with you later on. All attendees are muted today. If you have any questions, you're welcome to use the question box. And put your questions there, and at the end we'll try to answer those questions during the Q&A session. If there are any open questions that we're not able to answer due to time restrictions or even the content, then we will get back to you separately. Everything is locked, so you'll definitely get your answer. Oops. So as for the agenda today, I'll give you a little background on the Applanix history, not too much in detail. We'll speak about POSPac MMS and give you an introduction. What are the POSPac processing modes that we support? What are the core features in POSPac? I'll give you a little idea about POSPac Cloud for land application. Also, we'll address some questions about the installation and the licensing, and finally give you also the latest POSPac news in that webinar, followed by the Q&A session. First of all, background and history of Applanix. Basically, a detailed history information was given in the first mobile mapping webinar, which is still available on our webinar center, as I said before. So I will not go through all the details here. Just in short, Applanix had his 30th anniversary last year, and we are the pioneers for GNSS inertial integration with deep knowledge on the inertial technology side. For almost 20 years, we've also been leveraging the Trimble's outstanding know-how in the GNSS technology to provide high-quality direct referencing products to the market. And that in terms of hardware as well as firmware, and of course, post-processing software, which we are speaking about today. So POSPac introduction. What is POSPac MMS? So POSPac MMS is Applanix GNSS aided inertial post-processing software for georeferencing of sensor data such as camera, LiDAR, radar, multi-beam, and hyperspectral. Based on the list of the sensors mentioned here, you will realize that POSPac is also a software where you can process other data. It's not only from mobile mapping industry, but also from airborne side or marine kinematic surveys. What you're doing here is you create a robust, precise position and orientation by using base station data or real-time correction data, also known as RTK, or any other post-correction data. And what you import into POSPac is basically the raw data from your POS system, the base station data, if you have some. If not, then POSPac can help you to get some. You put that all into POSPac, and POSPac then generates the trajectory, which we call the SBET solution, and that stands for Smooth Best Estimate of Trajectory. And eventually, you will then use the exterior orientation processor or the export function to export your direct georeferencing data in a certain coordinate system, like a certain mapping frame, at a certain interval for your sensor data. The technology that we've been using here is called ion fusion. This is basically a single Kalman filter process where the primary sensor is always the inertial measurement unit. So the inertial measurement unit is basically measuring the angular rates and the acceleration. And if you integrate over the angular rates and acceleration, you will get position orientation information. But as for any other IMU, the position and orientation information is biased by errors. We need to understand those errors. So in the error controller, we're estimating those errors by getting the aiding sensors into the Kalman filter process. And the aiding sensors are the primary GNSS receiver, DMI, for instance, which is an odometer giving you distance, and or GAMS, which is the GPS azimuth measurement system, if that second antenna is being used here. So the aiding sensors are really helping us to understand the errors of the IMU. Once we understand the errors of the IMU, which are basically bias and scale factors, then we can write the corrected navigation from that mechanism. The Kalman filter does also run an on-the-fly ambiguity resolution. And we speak about on-the-fly ambiguity resolution, then that refers to the GNSS technology and the data from the GNSS receiver. So we are running and using here an inertially aided kinematic ambiguity resolution mechanism or technique that basically maintains the inertial position accuracy during the GNSS outages. And it maintains kind of a memory of those ambiguities. And eventually that aids in rapid ambiguity resolution after an outage, leading to an improved ability to maintain centimeter position accuracy. So I mentioned the word ambiguity quite often now. So let's explain what that is and what is meant by that. It's quite important to understand this so that you can also evaluate the performance and prospect of your process trajectory. So there's basically an electromagnetic wave transmitted from the satellite to the receiver at a certain frequency, resulting in a specific wavelength. So for GPS, for instance, the L1 signal, that results in a 19 centimeter wavelength, whereas the frequency is 1,575 megahertz. So within this cycle, the distance and range that we target to get here is determined by phase differencing, which is basically a signal comparison between the satellite and the receiver. That part is straightforward, but determining the integer number of cycles between the satellite and the receiver is a challenge. And of course, we need the number of cycles to calculate the range. Having 4 ranges from 4 satellites will give us a position on the ground. So the precise distance or range and hence a precise position is a function of the number of cycles. And that is called ambiguity. Knowing the exact number of integers, knowing the exact integer number results in a fixed solution. Otherwise, it's going to be a float solution, or you may have scenarios where you have no solution. While fixed solution means you have centimeter level of accuracy, float solution could mean you have also only decimeter level of accuracy. But that still depends on the quality of the IMU and how long the period is that you are exposed to a float solution. The other thing that I wanted to bring to your attention is the automatic transformation that's happening in POSPac. So when you load a base station into POSPac, the base station typically comes with coordinates. You need to declare in what frame the coordinates are saved actually for that specific base station. So for instance, in Europe, the most common frame that's being used here is the European Terrestrial Reference System called ETRS 89. That's similar like in North America, where the NAT 83 is used, or in Australia, we have the GDA 2020. So you have to tell POSPac, my coordinates of that base station are in that specific frame. And then what POSPac does, it does transformation into an international reference system at the mission epoch. That's called ITRF00 at mission epoch. So your SBED will be in that international reference system. And the reason is that all the service files that we can download for GNSS are going to be in that frame at that epoch. And then eventually, when you export your solution, you run the XT orientation processor or just the export function. At that time, you will again tell the software, okay, I want to have now my target mapping frame, for instance, back to the ETRS 89 or back to the NAT 83. That's quite important to understand that workflow and what's happening here in POSPac to avoid any datum shifts in your data. Okay, so at that point, I'll hand over to Christian, who will now present the POSPac processing modes.
Okay, thank you, Nico. So in the next chapter, I would like to talk about the different processing modes which are available in POSPac, and the main difference of these modes is the way how we use the base station or correction data. The first and most simplest way to process POS data in POSPac is the single base mode, which utilize one single base station, which should be located within a 20 to 30 kilometer range to your mission area. The base station itself could be a physical station or a virtual station. This doesn't matter at this point. Yeah, with the assumption that the rover and base observe the same GNSS errors like atmospheric errors, clock and orbit errors. These kind of errors can be eliminated, and the ambiguities can be resolved in the adjacent area of the base station, and the errors which increase with the distance to the base station can be calibrated. So this is the main concept behind using a base station data. And yeah, and for single base, it's important to keep this restriction in mind, that the base station or base rover separation should not exceed 20 to 30 kilometers. Instead of using a base station, somehow it does not go to the next slide. Yeah, thank you. Instead of using a base station, the single base mode can also be used when real-time correction data was recorded during the data acquisition. So in this case, we have here an example. In this case, there's a virtual base station which follows the location, the rover location, to minimize the rover base separation. So this is an example, a screenshot from POSPac. So you see the trajectory, you see with blue flags the position of the virtual reference station. So this is the concept when you recorded real-time correction data, and yeah, the real-time correction data can be used in the single base mode. Next, please. So the next processing mode is the smart base method or approach. The smart base mode uses multiple base stations, and this is especially suitable for larger mission areas where the base rover separation is larger than 30 kilometers. To get these base station data, POSPac has a built-in tool which gives you access to free available base station data worldwide. So you can use this tool to download and import the base station data directly into POSPac. when the base station is imported, POSPac will derive the so-called smart base region from these base station data, and this is what we see here on the screenshot. We have the base stations as green dots, and these base stations surround the mission area, and the area in between is the smart base region. And then the VRS concept again is used to estimate errors at the rover location. There's also a network adjustment functionality to ensure that the base coordinates match to each other. And with the custom database or user database for base station data, it is also possible to include or to use external sources to use, for example, other GNSS services if available. From POSPac version 8.7 onwards, Rhinex version 3 is also supported. This is during the download of base stations and during the smart base processing. Oh, now it's working again. Okay, the next processing mode is the multi-single base processing approach. This method is for situations where neither single base nor smart base is suitable, like corridor mapping. In this case, you can use multi-single base. Here you need multiple base stations, again, which are located along the trajectory, as you can see in the screenshot. And the processing, the algorithm itself, choose the nearest station during the processing to keep the rover base separation below 20-25 kilometers. So the base station separation should not exceed 40 kilometers, like it is shown in the slide. So this is more a special processing mode, or a processing mode for more specific kind of situations. So the next processing mode I want to talk about is PPRTX. PPRTX stands for Post-Process RTX, and it is a GNSS correction service in POSPac, which is based on Trimble's RTX technology. Trimble RTX consists of a global network of tracking stations collecting continuous data, which is then processed in the control center. And the control center, or within the control center, a smart algorithm derive a set of correction data for the rover position. And in POSPac, you can use this set of correction data just minutes after your mission to process your data. So this is especially or very powerful if you do not have any base stations available, and then you can directly get your correction data within POSPac over this functionality. For using this PPRTX in POSPac, a separate subscription license is needed. There we have a 6-month or 12-month license available. PPRTX has PPRTX has two kind of regions. First, the fast region, which are Central Europe and North America. Here, a regional correction model is used. Therefore, the convergence time is within 1 to 2 minutes to reach the final accuracy. The recommendation here is to have at least 10 minutes of rover data, or your mission duration should be at least 10 minutes. The rest of the world is then the standard region, where a global model is used for the correction data, and the convergence time here is 15 minutes or approximately 15 minutes. So our recommendation is to have at least 30 minutes of rover data, or the mission duration should be at least 30 minutes. So the question is now, is PPRTX suitable for mobile mapping in a land application? So the answer is partially. So PPRTX is very reliable and well established for open sky environments or open sky situations. And on the other hand, it is not recommended for using it in urban areas due to the potential degraded GNSS signal in these kind of situations. We hope or we expect that the performance will get better with the next generation of PPRTX, which supports then the third generation of Baidu satellites. So for the future, we are optimistic that PPRTX is also a good option for land application. Okay, to sum up this chapter, here we have an overview of the different processing modes in POSPac. For land application, the focus is definitely on single base, smart base, and multi-single base. So these are the three main processing modes which are available. And for the future, as I already mentioned, PPRTX is hopefully also a good option for land application. PPP and the loosely coupled methods doesn't play a role here. Okay, and then I would like to hand over again to Nico.
Yes, let me get the next slide.
Yeah. Oh, okay.
Yeah, thank you very much, Christian. So let's focus now on POSPac core features to give you some ideas about the most important features here. So what happens if you load a base station but you don't have the coordinates? So there's a nice feature here that we call RTX survey in function. Basically, you would need to make a right mouse click on your base station from the left side of the Project Explorer, and then click on Compute RTX Coordinates. That function will call the Trimble RTX service, and it will survey in your base station. It will determine the coordinates of your base station. So that means even if you don't trust some of the base station that you can source somewhere from different suppliers or free services, whatever, you can always check and control the coordinates of the base station. The minimum requirements are that you have clean L1 and L2 data, so the phase measurements L1 and L2 from GPS for about 60 minutes. I've seen it also working for less, but the good thing is that you always get a feedback from that service about the accuracy. So having only a few minutes of data, obviously you don't get the high level of reliability because there's not redundant information available. So we suggest an hour of data at the minimum. These supported formats are the standard RANX file formats, as well as the native Trimble format. And what's very important is that the antenna that's being used here is a calibrated antenna model. And there's a list here on that website that we show here. There's a long list of all the calibrated antenna models. So again, it's important that the antenna that's being used is a known antenna. Otherwise, the RTX survey in functionality may not work. Another very exciting feature is our LiDAR QC tools. LiDAR QC tools would support the boreshead calibration of your LiDAR sensor. In addition, it will also generate a LAS file, which is a point cloud in a very known, famous format in the mapping world. So it would create that LAS file. You can apply the boreshead angles or not, depends on what you want to do. And the algorithm that's being used here is based on a robust iterative least-squares adjustment using 3D voxels from overlapping point clouds. So for those of you who are familiar with the photogrammetry, it's quite a similar process. In photogrammetry, you work with pixels on the images, and the arrow triangulation, you would tie the images together with the tie points in the overlapping areas of the images. So in this case, it's a 3D point cloud, so we don't speak about pixels, we speak about the 3D voxels, but the principle is basically the same. So back to the boreshead calibration. This is also known as a misalignment between the IMU and the LiDAR sensor. And in order to obtain the highest level of georeferencing accuracy for LiDAR sensors, it is important to know the angular misalignment between the IMU and the LiDAR sensor. So the LiDAR raw data need to be in the native LiDAR frame and time tagged with the GNSS INS data from our POS. The specific boresight pattern is suggested and is outlined in a technical document that we share with our customers. And LiDAR QC requires a separate license. It's not coming with the GNSS inertial processing license. It's a separate license, which is available as a perpetual license or a term license. What we expect in the future is an adjustment function as well. So with this adjustment function, you can even correct the trajectory in, let's say, critical GNSS areas, such as in multipath environments or even denied GNSS areas, based on the LiDAR data. So the LiDAR sensor becomes like an aiding sensor to correct your trajectory. And it's working like a SLAM, for those of you who have heard about that before. And yeah, the LiDAR basically contributes to the trajectory optimization. This function is already kind of working with the term license that we distribute, but it requires tuning and tweaking, of course. But for those of you who are interested to play around with it, we are always eager to give trial licenses out for you to test it and then report back your results so that we can learn and optimize the algorithm here. POSPac licensing. So the principle that we support here is a very famous network license concept, which is also known as a concurrent license. So that works in a client server environment, and you can share your license within your organization. You can also commute or check out a license for any field work or remote work where you don't have any access to your server, so to your IP range, for instance. And if you have any field work, just get it on your laptop, you go out to the field, and you can work there. It also supports multi-seats. So if you're in a high production environment, you probably one license may not be sufficient. You can just purchase another seat on top of it or another seat on top of that to allow parallel processing of data. Yeah, I think the second or the third seat is even cheaper than the first license. You would even save money at some point. And moving the license around is very important too. So that's possible, of course. So if for some reason a specific computer is not wanted anymore, you can just move the license from one to the other machine, or the machine is outdated, whatever, it's old or damaged. Hopefully you can move the license before it gets damaged, but that is possible with this license concept. In terms of the business model that we pursue here, we are basically supporting the traditional perpetual license approach with the maintenance concept. So perpetual license means you're buying a license and you become really owner of it. And in order to update your POSPac version, you will need to buy the maintenance as well, which is basically annual maintenance concept. However, last year, we also released a so-called term license concept. A term license always runs 12 months, and it's similar like a subscription approach. The idea here is that you are able to reduce your upfront investment because a term license is far cheaper than a perpetual license. So you can reduce the upfront investment. You can hopefully easier budget your cost. And the other thing is that you would always use the latest and the greatest software version here when you're having a term license, because the maintenance is basically included. Another feature is the QC report in the publish function. QC report is basically a summary of your processing results, where a lot of information, metadata, as well as plots or graphs are going to be stored in a PDF file. And that makes it interesting in case of you want to share the results of your processing, let's say within your department, with other colleagues, or even with your customers, right? This QC report is also customizable. So if you don't want to see all of those graphs and all of the information, you can tailor it to your needs or even to your customer needs. And you can present the results in a way you think it's good to hand it over to someone. And the same for the publish function that allows to zip all relevant files generated from the processing, including the log files. And you can share easily a project with other people, also with your customer, for instance. And the same here, you can customize the content of this publish function, again, to tailor it exactly to your needs. Batch command line executable is part of the standard POSPac installation package. With the batch command line, you can automate processing in your production environment, which means that you can create a batch template with, let's say, standard settings that you always apply for certain projects or even many projects. For instance, you can define, okay, this is going to be always my output format. I'm using that coordinate system. Here's a set of my lever arms. Here's the export interval. All of that can be defined in a single batch template and then be used for many, many projects. And of course, that also means you can reduce the risk of errors, right? Instead of having an operator sitting in front of the software who can obviously make mistakes, humans always can make mistakes. You can automate the process. You can make sure there's less risk of errors, and you can streamline your production in terms of you acquire all the data a full day, then put it in a batch file, and let it run overnight, and next day you have the result. So of course, there's no POSPac graphical user interface here. It's a command line, as we said. And we do have also a dedicated command line version for POSPac MMS for OEMs and integrators. So that being said, the batch command line can also be integrated in your own software graphical user interface. So you can basically hide that in your own software if you want to. The batch command line supports all business lines, processing modes, all IMUs, as well as LiDAR-QC, RTX survey-in, PPRTX, everything that we spoke about today, it's going to be supported in batch command line. There's no serious restrictions or anything. Okay, so next one is POSPac Cloud for land. That's a very interesting product for many customers, I believe, and I hope. So the first POSPac Cloud launch addressed the UAV and drone market, but now we are also ready for other market segments to onboard, such as mobile mapping. We do have an application program interface, API in short, for OEMs and integrators, but potentially also for customers who are in a high production environment. And the business model that we target here is a transactional or subscription-based business model. So we would be charging customers based on per kilometer driven data. Of course, there's going to be a minimal commitment here as well, because we really target high volume of data. It only makes sense if there's let's say, a certain amount of data being processed through the cloud. Same here, it supports all features and benefits from the desktop POSPac software. And basically what you would need to do at your end is create that batch XML file. With the batch XML file and the rover data and the base data, they're going to be uploaded to the cloud, and then the processing will happen. Again, if you don't have base station data, POSPac will also be able to download some of those free stations. And what we also support is going to be so-called custom files. So if you have a very specific output format, or let's say you have a very specific mapping frame that's not default available in POSPac, this is all going to be supported through the cloud approach. We do have a production environment and a staging environment for POSPac Cloud. Production, obviously, as it says, is for the production environment in the sense of as soon as you process any data there on the production servers, that will be chargeable data. The staging environment, however, is for all the integration work, for testing purposes, etc., where there's no additional charge behind that. And of course, from a cloud service, you would expect it always runs, since we have a server monitoring, therefore, and since we have a server monitoring the service running permanently, we've got to check that all the connections, all the server included in that workflow are running and they are up and running all the time, basically. So we do have a server health check status page here where you can subscribe to in order to obtain email notifications for potential planned or unplanned outages. A planned outage, for instance, if the POSPac version is going to be updated, or there's any other IT updates running on those servers, then this is going to be a planned outage where you will be notified sufficient time before, so you can address your address your time slots for processing, and any unplanned outages. They're all going to be displayed on that status page, so you have a really permanent monitoring mode of all the servers in that cloud environment. Okay, so with this one, I'll hand over again to Christian, who will say something about the installation and licensing.
Thank you, Nico. Okay, in the next chapter, I would like to give you some general information about the installation of POSPac and how to manage the licenses. Okay, the first step is to download the POSPac software. You can find various versions at our Applanix support hub. The link is given here on this slide. It's accessible from our website. Beside POSPac, you will find other software products and other helpful information. So we would recommend in general to visit the site. You find a lot of helpful information and some tutorial videos there beside the software products. The installation itself, it's quite straightforward with the installation wizard. The important part here is to execute the installer with admin rights. After the successful installation, the next step is to activate the license. To manage the license, we have a specific tool, the software license utility. It is also a standalone tool for managing the license. Here you can activate, deactivate, and upgrade the license. For these actions, internet access is needed. You can also configure the license server. If you use the server client model, you can also set up here everything. If you have one license server running within your company or within your network, and then you can also set up here the client machines. Then the next slide is about commute a license. So Nico already mentioned this. There is a possibility to commute a license or to check out a license in case the license is needed outside the company's network. Here, you can check out specific license features for a specific time period from the server. So what we see here, we have two software license utilities open. On the left side is the license server, and on the right side, the client machine. And you can select, as I said, the license server, license features, specify the time. For example, in this case, the license features were checked out for 2 days. And then you can leave the network, you can leave the company's network when you are working remotely, for example, without access to the license server. And on the license server itself, the checked out license features are shown as in use. So the license is used and it's not available anymore for the time when this is checked out. After the time, the license features are checked in automatically. Okay, coming now to the last chapter of this presentation, I would like to show you some of the milestones or key developments which come with the latest version of POSPac. Some kind of latest news. We have an improved overall performance for the GNSS inertial processing, especially for situations where you have a degraded GNSS signal. We have added the new hardware generation IP Plus for land applications. As I mentioned, Rhinex version 3 format is now supported during downloading the base station data and during smart base processing. Term licenses are supported, as Nico mentioned. The license server or service on our side moved or migrated to a cloud hosted environment to improve the robustness. And there is the functionality now to automatically calibrate the lever arm for validation purposes. So lever arm calibration is a manual process, but with the last version of POSPac, there's now the possibility to perform this lever arm calibration automatically. Yeah, I think with this, we reach the end of the presentation, and I think we can directly continue with our Q&A session.
Yeah, sounds good, Christian. Thank you very much. So if you could check if we have any questions on the question box, and then
we have
through that, and we can start.
Okay, we have some. The first I would like to forward to you, Nico, is one question: when POSPac MMS can launch a camera QC for land?
Sorry, say again. When POSPac MMS can launch
or can support
QC for land?
Will support camera QC for land was the question.
Yeah, well, interesting question, because it just copies LiDAR QC to camera QC. We do have a camera QC mode there, which is called KaiQC right now. KaiQC is the counterpart for calibration of camera data, such as boresight calibration, but also interior orientation of the camera. So the KaiQC engine or KaiQC module does exist, but this is only for airborne application right now, not for land application. We, in fact, do have something in mind for land application, but that's really too early to address and speak about.
Okay, thank you. The next question is there any plan to create batch processing within the graphical user interface? When we are processing UAS LiDAR data, we often have 10 to 15 flights. Being able to set up a batch process within the GUI would be very useful and quick. So the question was, is there any plan to create batch processing within the graphical user interface?
That function is already there. So we do have the batch processing GUI mode, so you can create your batch file. Let's say you have a project out of 10 missions or something like that. You can easily create that right now in the batch mode, and there's a GUI to do that. So that function definitely is available in POSPac, and it has been there for a while.
Okay, thank you. Then I think we have another question, but I would say we will answer this later on with a private message or email. Yeah, I think. Then I can just continue. with other questions we have, what data frequency and time span is required for base station used in single base mode?
I'd say in the base mode, we really suggest to have the data frequency set to 1 Hertz. So 1 second data of the base station is what we strongly recommend. If you have, let's say, only 30 seconds, the POSPac software is smart enough to cope with it by interpolation. But of course, as soon as you interpolate, you are not having true measurements, right? So we strongly advise to have 1 second data for single base processing.
Okay, thank you. Okay, there's another question. Does the POSPac MMS support the Trimble ProPoint GNSS RTK engine?
Oh, I actually don't know what that is, I confess. I think we'll have to dig into this one and get back to the requester later on. In general, if you have a base station from various manufacturers, and of course, especially also from Trimble, you can use that. If you have real-time RTK information from a network supplier of correction data or from a specific base station, as long as standard correction data streams like RTCM or CMR plus or CMRX, that's all supported. I just don't know if that connects to Trimble ProPoint GNSS RTK. We have to dig that up and then get back to you.
Yeah, there was another specific question about Trimble R12 reference stations, if this is supported, and I think we will answer this later on with you.
Well, I don't see an issue there because an R12 is just a basic GNSS receiver, to my understanding, and it should create the native Trimble format, which is a T02 file format. And the T02 file format can, of course, be loaded into POSPac and then be used as a reference, or from any Trimble receiver, you can also convert it to the RINEX file format with the RINEX conversion tool that's supplied by Trimble. As I said, so RINEX files are, of course, all supported in the POSPac. So I don't see an issue with that.
Yeah. This question was specifically related for processing UAV data, but I think there's no, it makes no difference.
Yeah, it's not. So the base station can be used for all of the various business lines, whether it's airborne, land, or UAV or marine, doesn't matter. So it's as long as it's a base station and comes in a T02 file, which is a native format, or in a RINEX file format, and it has that 1 second data interval, you can put it into POSPac and run the processing without an issue.
No. Okay. Does the batch command line require a separate license?
No, it's part of the standard GNSS inertial license. I mentioned already before, we do have the perpetual license for GNSS inertial processing, but we also have the term license. You would need to have one of those licenses, and then the batch command line will work. So there's no extra charge, no extra license needed to run the batch command line. It's part of the standard installation package of POSPac.
Then another one, what is the expected accuracy for PPRTX?
Yeah, so as you mentioned, Christian, we'll have to be in a, let's say, open sky terrain right now. And if you're in an open sky environment, then the expectation is you can achieve 3 centimeter horizontal RMS and about 5 to 6 centimeter vertical. Again, this is probably not occurring if you're in a dense urban environment or even foliage areas where you have outages and multipath effects, because that may cause the filter to reset. You learned there's some convergence time needed for PPRTX, and if the filter has to reset because all the satellite disappeared or many disappeared, then that convergence time may start again. And that's probably not what we want to have. In that case, the accuracy will be not 3 or 6 centimeter, but in open sky terrain, like if you do highway surveys where you have good visibilities to the satellites, 3 to 6 centimeters is what we know and what we convey to customers. Yeah.
Yeah, then there's another question. Does POSPac MMS run on Linux in the future?
No, we have no plans for that.
Then there's another question. Is there any advantage in collecting base station data at a higher logging rate than 1 second?
No, as far as we know and what we've done with all the data processing and investigation, we don't see any benefit to log at the higher frequency than 1 hertz. Don't forget the inertial measurement unit is our primary sensor here, and that one logs data in a frequency of 200 hertz. And then having the aiding sensor such as GNSS for a frequency of 1 hertz is absolutely sufficient. So we don't expect any significant benefit for higher intervals of the base station data.
Okay, thank you. And then there is another question: how to add a mapping frame if a specific one that I need does not exist?
Yeah, that's pretty open in POSPac. Right now, you can easily add a mapping frame in POSPac. You would need to check first that the projection is supported. We'll support a wide range of various projections. But if the projection is supported in POSPac, you can add any mapping frame or any grid to POSPac as long as you have the parameters. So you would need to have the projection parameters, and then you would need to have the datum parameters. Datum typically consists of 7 parameters, like translation, rotation, and the scale factor between the ellipsoids. If you have that information and you have the information of the projection parameters, you can basically add any mapping frame that you want in POSPac.
Okay, thank you. Yeah, I think there is no other open question at the moment.
Okay, if there's no other question, then I believe we can glue it up. There's nothing coming in again, Christian. There's nothing new.
Yeah, there's recently one. Does the POSPac MMS can support other GNSS INS systems such as CPT7 from Novatel in the future?
No, that's not done. So everything that POSPac does support is our product line, our POS systems, AP Plus, AP exports, etc. All of those data, but not third-party data in terms of GNSS INS, for sure not.
Yeah.
Okay. So
thank you.
If that's all from the Q&A session, then I wanted to thank you for your attention today. And hopefully we'll meet you again in one of our other webinars. So thank you very much and stay healthy and see you again. Bye-bye then.
Bye.